already has happened. Dashboards are optimized for reporting, not decisions. While the dashboards excel at organizing historical data, but what they lack is forward looking intelligence for strategic choices. However, strategy requires foresight. Competitive advantage comes from anticipating market shifts and acting before competitors, not from analyzing yesterday's results. Now, why this gap matters? To be very honest, speed matters more than perfect timing. Markets move faster than reporting cycle. So think about the last time you were in a meeting where you received a report about sales, but the decision that you need to take is for the forward looking. By the time you have received information about sales or stock or inventory, that inventory was you were low on the inventory, you have already missed an opportunity over there. So dashboard did provide you a good insight on, yes, we were low on inventory, but how can we address this going forward is not what we are able to get from the dashboard, right? So due to these late decisions, it has destroyed value. The delayed responses to the market signal also resulted in missed opportunities. It has eroded margins and competitive disadvantages. Now, anticipation creates the advantage over here. So, what organizations like is organizations like to predict and act early so that they can capture the market leadership and establish the market leadership as well. The predictive analytics, it's a key technique. It's a toolbox. Basically, you use these different tools for different business questions. So over here, I want to go over some of the techniques that predictive analytics provide. We will go over one or two business use case, how they are implemented. The objective is not to go into the detail about the implementation phase, rather than understanding what are some of the use cases that are tied with these analytics. So let's begin with regression analysis. What it does is it identifies relationship between variables to forecast continuous outcomes like revenue, demand, or pricing. So in the retail organization, they will forecast next quarter sales or maybe next year sales based on price, promo, or marketing spend. The next one is classification algorithm. In the classification algorithm, it predicts categorical outcomes such as customer churn, fraud detection, or risk classification. One very classic example over here is we all must have like an account or a subscription with a company. So company typically look at the churn rate and this offer you incentives for retention. So once they start seeing over there that, oh, a customer is going to fall under the churn, the risk is very high, they start providing you maybe $10 off or $20 off of next promotion, and they start sending those kind of incentives so that you are still subscribed to their um, platform. The next is time series analysis. In the time series analysis, we identify patterns over time. We look at seasonality, we look at trends, and then using this, we forecast values based on historical time order data. A very classic example, like, very recently we have gone through the holiday season. The traffic, the demand is very high for airline pricing. So how do they determine those? They use time series analysis over there. An airline will use time series to predict seasonal ticket demand, and then they will adjust the flight capacity ahead of the season. So over here, seasonality is a big factor. We, in the similar way, think about now we are getting into the summer season. Soon we'll be into the summer season. That's when a lot of travel happens. A lot of kids are out of school. So there will be a lot more demand for the hotels, for the airlines. So they look at the seasonality that, okay, this is the time of the year when people travel a lot, and using the seasonality, forecast will happen, and they will adjust the pricing as well as the demand for it, and the remaining capacity gets adjusted. The next one is the clustering technique. In the clustering technique, you're going to group similar data points to uncover hidden patterns, customer segments, and market opportunity. So we all have, like everyone over here, I'm presuming, will have at least one streaming device or a platform they might be using. And you start seeing those recommendations that, okay, I have been watching content, say K-pop, right? Or maybe some K-dramas. And then you start seeing those more and more recommendations starts to come in. Why is it happening? It's the personalized content recommendation that is happening behind the scene. So the streaming platform creates those clusters to understand user behavior. And using those, they tailor to the personalized content recommendation. Then comes the decision tree, another technique within the predictive analytics space. It helps us explain why prediction was made and what actions to take. A classic example is when you submit a loan to the bank uses, bank will either approve or reject your loan application, but they will also provide you why they rejected your application. One of the reason could be, and it is coming off of decision tree, that maybe your credit score is too low, or your debt ratio is too high, or it could be any other information that they might have gathered. So those are some of the examples of how decision tree works within the banking space. Lastly, we look at the neural network. This is used when you are looking at the complex non-linear relationships within the large data sets, and you want to make a prediction. So for an e-commerce website where multiple products are available, it's hard for anyone to look at certain patterns, and it gets very complex. So neural network can help you in identifying and predicting what the next purchase for the customer would be, and they start providing those kind of recommendations. Now, predictive analytics, it's a capability, and it stands on multiple pillars. If one of the pillar breaks, the overall system is gonna fall down, right? So let's look at what are those pillars within the predictive analytics space. The first one is data foundation, predictive models, decision process, governance, and trust, right? So we can just let's talk about an example how this can be implemented within that space, right? Let's say you want to understand what does the current market growth looks like, as well as where should we be investing within the space. In order to understand that, there are multiple things that needs to happen. That you want to know what does the growth looks like. Then you want to look at the market size and what does the future prediction for those growth is for next 5 years. Right? So first thing is you're going to create the data foundation layer. What you're going to do over there is you're going to clean and integrate multiple data points over here. That will enable you reliable model training as well as real-time scoring across enterprise systems. Right? So over here, the market, sales, other economic data will be put together, and a data layer will be created. Now, using these data layers, you're going to apply the models on the top of it. So an advanced algorithm or an AI system will identify those patterns and come up with a forecast, and it will generate some actionable insights at scale. So over here, a regression-based market sizing model will estimate what does the total market looks like in the next 5 years, and what does the value looks like. So it will help you understand if the market is shrinking or is it expanding, and what kind of actions you can take. The next process over here, or next pillar over here, is the decision process. So that's when your strategy team can step in and start using these predictions and understand, do we want to enter into the new market? Do we want to stay within the market? Should we be reallocating some of our budgets? How does the investment should look like, right? So the structured workflow that will translate these predictions into a clear action plan. And at the same time, you will have a defined ownership and accountability within this decision process. And lastly, you want to enhance your models. You want to keep up on the top of it with all the relevant information. So governance and trust comes into picture. So a transparent model validation needs to happen. You would apply ethical AI practices and a robust monitoring system so that your stakeholders will have confidence in those predictions. It's not a black box, but they will know more about what kind of economic data or a trends that has been utilized. So those kind of informations are captured over governance and trust. Now, how does this prediction move into a strategic impact? Right? Prediction will only matter when it leads to action. So the very first thing in the prediction is an advanced model is generated using these forecasts and identify patterns that signal future outcomes and opportunity. A business example over here is a model that predicts the customer segments. Now in the within the marketing space, let's look at like another domain of marketing space, and we can understand within the marketing space how this can be applied. Right? Right? So a model will predict which customer segments are most likely to respond to your marketing campaign. So once you have identified, okay, these are my customer segments, those things are delivered to your marketing teams. And an expert over there, a domain expert, will translate these outputs into a business context and implications. They will also talk about what are the trade-offs. So once the marketing team analyzes these predictions, they can utilize they will identify what are some of our high value segments and preferred channels where these campaigns should be launched. Then comes the decision step. In the decision steps, the leadership team steps in and decides that, okay, we want to launch the campaign. So we want to make use of, or we want to reallocate some of our budgets so that we can get those high conversion segments. Right? So a leadership team commits to a specific action plan over here. And based on those interpreted insights, strategic priorities are realigned. In the end, the operational team comes into the picture. They are the ones who are going to take action upon. So organization execute these actions rapidly. Rapidly is a very important word over here because you don't want to don't want to delay the insights from the prediction that you have received. So they will make the decisions rapidly, then monitor the results and adjust the course as new data emerges. So the campaign, your operational team will launch these campaigns. They will track all the KPIs daily or weekly or whatever the business needs are. And based on that, the marketing spend is reallocated in real-time based performance. Now, there's a one very good case study that I found, and I have a link at the bottom that talks about how a retailer was able to identify the opportunity using the predictive modeling. The challenge they had was they have 200 plus stores and they were experiencing significant inventory management issues over here. So they were either going out of stock or there was too much of inventory over there. Historically, what they have done was they were using the average and the manual adjustments were being done. But when you look at 200 stores, it becomes a very challenging and a critical task. It consumes a lot of effort and the chances of errors are significantly higher. The inventory decisions were taken, therefore, quarterly based on last year's sales data. But as we talk about, the consumer signals can change significantly in a short period of time. They were not able to capture these kind of signals as part of this traditional approach. And what they utilized was they were missing out on 4.2 million annual ROS due to either markdowns or stockouts, because when they have too much of inventory, they ended up marking down the product and they were hitting out, and that's why the margin were compromised over there. So what was the solution? They came up with an approach where they wanted to implement an ensemble model combining a time series, regression, and external data sources. So some of the examples could be like local events over there. So think about you have Olympics next year. So during the Olympic season, you will see a lot more traffic around, and once there is a lot more traffic, then there will be a lot of spending that's going to happen. But when you look at the historical trends or historical data in your reporting system, that might not talk about it, or maybe a World Cup that's happening, right? So a lot more people will come into the city. So there will be a lot more again, because of the foot traffic. There will be more purchasing that's going to happen. People will shop around. So those kind of things are not captured as part of this traditional approach, because you were looking at just the reports. What does a sales number look like? But within your model, you can have all these as an input, and then that can help you in identifying and forecasting your future demand, right? So the implementation phase, the first thing they did was they did the data assessment. What kind of data we need, what kind of indicators we want to bring in, what are the some of the relevant information that we can utilize as part of building these models. Then the very next stage is the data cleaning process. Once the data was cleaned, they automated these pipelines, and the model was trained using the last 3 years data. Yes, still you want to use your historical data, but with all these indicators, with the use of all these indicators. And then the merchandising team was brought into the picture. So because they are the experts, they understand more about how inventory to be positioned, as well as how the categories are positioned within their merchandising space. So they were involved, and then they were trained on these new systems. Using these new systems, they took the action upon. So what were the results? There was 47% reduction in the stockouts. The excess inventory, again, that dropped. They saw a gross margin increase, because as we talked about, when you're doing a too much of markdown, you're talking about hitting on your gross margins, right? So the gross margin was, there was an increase in the gross margin, and ROI they saw was significantly higher, 342% within the first year itself. So there's like one of the case study that I found that I felt it's very useful to read about, to read through. So I have a link at the bottom. Feel free to look at it, and if you have any questions or you want to discuss about it, happy to talk about it as well. Now we talk about all the good parts of, yes, predictive model works very well, but actually a good model can fail as well, and it still fails just because people are chasing accuracy. So one of the very recently I was reading some article, and I noticed that a person, he has an 87% accuracy on his model prediction, and they kept on going for, okay, I want to increase the prediction, and they were able to go up to 89%, right? The 2% increase. But what, for those 2%, they ended up spending about 2 months increasing the ROI. There was hardly an ROI, because the decisions were based off of at a very high level, that the business was very much comfortable within the 87%. So those, that making the model even better was really, at that point of time, wasn't very relevant, because it was still very good. So understanding that is a huge piece. So even a sophisticated model will fail to create a value when organizations prevent this effective use, right? So insights are not trusted. This is like one of the very common problem we see, because these models are so black box that they lack transparency. So stakeholders really are hesitant on acting upon those recommendations, because if you don't know what's happening behind the scenes, what kind of input signals are utilized within those models, it's hard to believe the logic and trust those insights and recommendations. Another issue that we see is predictions are arriving very late. What that means is, a complex approval workflow process might happen, or there's a lot of batch processing delays are causing these. So you may want to revisit those things and making sure that they are not the barriers for your model to fail. And lastly, decisions do not change, because predictions fail to trigger action when organizations lack a clear protocol for translating these insights into an operation changes. So going on to the last piece of it, so what are the key takeaways, like how prediction can really help, like, not just the reporting piece. So the real advantage isn't just like having a better dashboard over here, but it is the ability to understand and predict early and act decisively. At the end, yes, dashboards are still needed. Dashboard will explain you the past, but strategy needs foresight. So you want to move beyond the retrospective reporting to forward-looking intelligence that anticipates those market shifts. Models don't create value, decisions do. So yes, decision. You really need to focus on making decision faster, right? So predictive accuracy means nothing without the organizational capability to act on these insights rapidly. Speed and trust determine impact. As we talked about speed, right? So value decays exponentially with delay, while transparency builds the confidence that is needed for stakeholders to take those actions upon, right? And human and AI creates advantages. So in the competitive landscape, it comes from combining machine learning prediction along with the human judgment and those domain expertise. Thank you. Do you have any questions on these?
Very good presentation, Manish. I really enjoyed it. It was something I was involved in back a few years ago, and very good. Any no questions from outside? Anyway, anybody here have any questions for Manish?
Yeah, actually, I will. I'll give a introduction. In the past, I studied economics, and I would do focus for financial department. But everything we did was manually, or it was either we built a model, but we set it up in Excel, or maybe connected to the database and did some data analysis. So my question is actually, what is the solution or the technical solution that you're offering? If it's not a dashboard, then what is it? It's a AI model. Is it something visual, or is it a chat box? On how can you rely on it if it's not giving you nonsense? Because you're talking about business and yeah. So
Mhm.
the question
So,
is,
very good
are you
question.
talking about an AI model, or what is the solution for prediction?
Yes, so very good question over here. What I'm saying is dashboards are really very important. It's still going to give you all the information. So I'm not saying that you should get rid of these dashboards, but the predictions that come out of it can also be pushed into a dashboard, right? And then you need domain experts to understand these predictions. So using those, you can interpret those results and take it forward. Because now within your dashboard systems, you will have the forward looking statements as well. So over here, you will need domain experts. You will need, so at the end of the day, it's human who's going to make the judgment. Read through those, look at what are some of the implications and trade-off of these predictions. Understand the overarching strategy or hierarchy of the market or economics or what kind of decisions you want to take. And then use a collective approach over here.
Okay, thank you.
So not to just say that we should get rid of dashboard. No, it's absolutely needed, but just don't rely purely for forward looking statement. Try to utilize it as maybe a reporting purposes that helps you in understanding, okay, what happened, but what is going to happen is where that predictive insights and analytics is going to come into picture.
Well, I think if BI or dashboards will have the component of a chat that you can ask the dashboard something, then
Mhm.
you're gaining the
Two
thing.
in one one
Uh,
in like solutions at one stop shop. Yes, definitely.
yeah, thank you.
Okay, thank you, Manish.
Thanks everyone.
Um, we got Precious up next, and there we have your screen. So if you want to, yep, got it. You're on mute there now.
Okay.
Yeah,
I guess everyone can hear me right
yeah,
now.
yeah. Can you?
Okay, welcome everyone once again today. I'm Precious and I'm here to present on network security group. But first of all, I'm going to introduce myself properly. My name is Precious Odnakachi Wazo, a cloud infrastructure engineer, specialized on Microsoft Azure. I am a founder and I anchor an anchor of Cloud and Beyond, a platform dedicated to breaking down cloud computing concepts into simple, practical lessons through through me documenting my learning journey and also creating space for beginners to explore cloud computing. So last week I was here and I talked about network security group, and I believe most of us understand network security group. The network I explained about network Azure Virtual Network pairing. I believe some of you understand what it is as a way of connecting virtual networks in Azure to communicate with each other. So today, through Microsoft Backbone Network connectivity. So today, I'm here to talk about network security group. So what is network security group in Azure? Network security group in Azure is more like a firewall that decides what goes in and out of a resource. In my slide, I have it. I think of it as a security guard for your Azure resources. It decides which traffic is allowed in or out of a resource. You set up the rules to allow traffic or block traffic, and also these rules protects your network from unwanted access. Now, when we talk about network security group, there are key concepts that makes up this topic. First, you have the inbound rules. The inbound rules controls traffic coming into your virtual machine or network. Example, when someone tries to connect to your website. Also, you have the outbound rule. The outbound rule controls traffic exiting your resource. Then we also have the default rules, which are built-in rules to keep things safe in Azure. Azure already created these default rules. You can add your rules on top of these rules. And these rules as well have the lowest priority number with the highest numbers. Now, also on my list, I have number 4, which is priority. Priority, which is if two rules conflict, the NSG follows the one with the higher priority. Like I said earlier, the lower the number, the higher the priority. Then the higher the number, the lower the priority. Then there are components of an NSG rules. Every NSG rule is made up of this part, the name, which is like the rule label. Then the priority is the number that decides which rule is checked first. Then the source indicates where the traffic comes from. Then the destination also indicates where the traffic is going. You also have the protocol. The protocol is more like the language the traffic speaks. You have the TCP protocol, the UDP protocol, the ICMP, or it can be any protocol at all. Then the port range, which acts as the doorway to the traffic. You can configure an NSG route to follow the path of port 443. And also I have direction, which is either the rule is configured to be inbound or outbound. Then the action the rule is going to take is either the rule is blocking the traffic or it's allowing the traffic into the resource or network. Now, this is a typical example of what an inbound rule looks like in network security group in Azure. Here you have, I stated, to ensure secure web communication, an NSG rule can be configured as follows. Source any, destination virtual network, protocol TCP, port 443, action allowed. This is a secure connection to a web server or anything in the internet, but with a secured connection. So this is a typical example of what the rule one can configure on the NSG looks like. There are capabilities of NSG. NSG is capable of combining two Azure resource services together. That is, NSG works together with tools like Azure Network Watcher to monitor logs and traffic. Also, flow logs. Think of this as a security camera recording of all traffic decisions. Who try to enter, who is getting blocked on the by the rule being configured. And also, I have the diagnostics. You can troubleshoot issues to check which rules are allowed or denying traffic. Then the integration with route table. NSG can be paired with routes, with custom routes to control not just who enters, but also the traffic, where it's going to, or how the traffic is going to flow. Then here I stated why NSGs are essential. Protection to your resources. The NSGs act like shield, blocking unwanted or harmful traffic from reaching your virtual machines or network. Also, it reduces risks. By filtering traffic, NSGs help prevent attacks, data breaches, and accidental exposure. Then it provides flexibility. You can apply rules at different levels. The rules can be applied either at the subnet level or the NIC level, giving you both security and fine-grained control. Now, also it also controls as they decide who can or cannot access a network. Now, the best practices for NSG: start simple, begin with only the rules you really need. Don't overload the NSG with too many rules at once. Check priorities. Remember, lower number equals higher priority. Always review to avoid conflict. Apply least privilege. Allow only traffic that is necessary. Block every other thing. Then also here, apply at the right level. Use subnet NSGs for broad control. Then NIC NSGs, network interface card NSGs, for specific controls. That's a direct control to a resource, specifically virtual machine. Monitor with logs. Regularly review flow logs to see what traffic is being allowed or denied. Regular audits. Update and clean up rules as your environment changes. Updated rules can create security gap. So this is the basic explanation I have for network security group. With this, I'm going to go over to my Azure portal to give a practical demonstration of what network security group rule looks like. So on my portal, I have already set up 2 virtual machines and also set up NSG. And I also I also configured NSG because I did this to make sure everything is running smoothly to avoid taking too much of our time. I connected the NSG to the subnet of the virtual network, and as well, I created application security group, and as well attached it to the NIC of these 2 VMs you can see here. So right now I'm going to go over to network security group to create a rule that would allow the VM server to be accessed through the internet. I also, before I forget, I also deployed a web server on the virtual machines, an Ignis web server on the virtual machine. So we are going to access this web server when I configure this. But if I try to access this web server, I can show it right now. I'm going to use the public IP of one of these virtual machines to access the web server, which I am not going to get access to. Then I would come back to configure the rules on the NSG to show that with the NSG being configured, you can easily access your web server. But I'm going to make use of port 80 HTTP. It's not a secured connection, but that is the one I resolved to use. So we are not going to reach the web server right now because the NSG rule has not been configured to. And also I'm going to start up my VM as well. So this is the network. This is the network security group I set up. You can see there is no configuration yet. So I'm going to set up an inbound rule to allow HTTP port 80 to set to on the virtual machines. Here, the inbound rule. So I'm going to add a rule here. I'm going to leave it as any. I swear this. I'm going to leave it on the default. But this, because I have already attached the NICs of the virtual machines to an NSG. I'm going to do the destination to be this. So I'm going to select my already created ASG as application security group where my NICs are being attached. Into HTTP. It's already picked this. I'm going to leave this priority number, or I can do anything less than this default number. It would still go as far as there is no number that is lower than this in my NSG. Now I'm going to set this to allow HTTP. Yes, so with this, I will go over to my virtual machine to copy the public IP of the virtual machine. And I'll try to access the internet with it to see the web server I deployed earlier. I hope I didn't make a mistake. I'm going to try this again. Okay, here. This is the Ignis web server I deployed earlier on the virtual machine. So if I want to go further, I can quickly deploy another virtual machine and attach the NIC to the NSG that is being configured under this rule that I set up on this NSG. Frank, I don't know if I have the time to go ahead and do that.
Yeah, we have two other speakers, so we'll go on to the next speaker. Is that okay?
Okay. So this is the little I have to show for today for NSG topic in Azure. I believe if anyone has any question, you can go ahead, please.
No, you're okay, and it was pretty clear your explanation of NSG. Very good. Thank you very much.
You're welcome.
The demo was great too.
Yeah, demo was good as well. Yeah. So, Parana, do you want to share your screen?
Sure. Let me know once you guys are able to see my screen. Are you guys able to see my screen?
Yeah, I see your screen there now.
Awesome. Awesome. Let me just expand this. Still good? No issues, right?
Yeah, I think your screen is fine. Yeah.
Perfect. Thank you. All right. So today my topic is modernization public services with modern metadata driven low code architecture in Salesforce. Public services today are expected to work like Amazon, which are like fast, simple, always available. But many government systems were designed decades ago. Citizens expect digital services that are accessible, mobile friendly, and transparent. Agencies are expected to deliver that while navigating strict regulations, security requirements, and limited technical resources. This creates tension, speed versus compliance, innovation versus stability. And today, I want to show how metadata driven low code architecture using Salesforce resolves this tension, not by cutting the corners, but by modernizing without breaking the trust. I, Pavana Kumar Dasu Madhusudan, I'm an independent researcher and I'm going to talk about this. Digital transformation imperatives. Public sector agencies face mounting pressure. They must deliver citizen centric digital services. At the same time, they operate within the complex regulatory environments. Legacy systems are everywhere. Budgets are constrained. Engineering capacity is limited. Traditional development struggles here, not because the team is weak, but because the system was never designed for a rapid change. Low code changes this equation. Low code, a strategic catalyst for government modernization. Low code used to be seen as an experimental. That perception has changed. Today, more than 60% of public sector agencies use low code platforms. Early adapter reports 40 to 70% faster deployment. Service availability consistently meets 99.9% uptime. There is no longer about convenience. This is production grade infrastructure in government. Uptime is not an optional. Session overview and learning objectives. In this session, we will focus on 5 areas. Flow orchestration for multi-stage workflows. Experience cloud for accessibility and inclusion. API first architecture for legacy integration. Government and security, public sector compliance. And a practical framework for adoption of low code in regulated environments. Salesforce flow orchestration, coordinating complex government workflows. Government workflows are rarely simple. A single request may cross multiple departments, approvals, reviews, external system. Flow orchestration coordinates these steps. Sequential, parallel, auditable. Every action is logged. Every decision is traceable. This is critical for compliance and auditability, and it can be done without service disruption. Breaking down the process bottlenecks. Recent flow enhancements improve error handling. Agencies can now implement retry logic, alternate paths, automated notifications. Instead of stalled cases and manual interventions, processes recover gratefully. In practice, this reduces bottlenecks by 60%. That directly improves citizens' experience. Experience Cloud extending public services to all the citizens. Modern public services must work for everyone. Experience Cloud supports multilingual deliverability with more than 25 languages. Accessibility is built in, so the WCAG 2.1 AA compliance comes with by default. Screen readers, keyboard navigations, adaptive interfaces. Citizens can access services on their desktops, tablets, for that reason on their mobiles as well, even in low connectivity areas. API first architecture, bridging legacy and modern systems. Modernization does not mean rewriting everything. Many agencies rely on mainframes, COBOL applications, long-standing, long-standing databases. These systems still work. API first architecture wraps them securely. Legacy systems, they still remain intact, and modern experiences are layered on the top. This this preserves investments, and enables incremental change. Meeting stringent public sector compliance requirements. In government, security is not a feature, it's a product. Salesforce Cloud, Government Cloud maintains FedRAMP high authorization. Role based access control enforces least privilege. Audit trail provides complete visibility. Data residency controls meets the jurisdictional requirements. This enables innovation without compromising the trust. Einstein Analytics, data driven decision making. Automation alone is not enough. Agencies need visibility. Einstein Analytics provides real time insights into service delivery, resource utilization, citizen engagement, predictive analytics, support planning. Anonymously detecting identifies issues early. If you cannot measure services, you cannot improve them. Measurable benefits, efficiency and technical overhead reduction. The benefits are clear. Faster deployment, fewer manual interventions, consistent standard compliance. Agencies do more with existing resources. Citizens receive services faster and more reliable. A practical framework for adoption in regulated environments. Successful adoption follows a pattern. Start with an assessment and planning. Select a pilot use case. Prove value. Establish governance early. Then scale what works and continuously optimize using analytics and feedback. Every successful transformation starts small. Bridging policy and engineering excellence. Public sector modernization lives between policy and engineering. Metadata driven architecture acts as a bridge. Policy team defines intent. Engineering team ensures the performance, security, and reliability. This alignment reduces the friction and accelerates the deliverability. Real world impact, accessible, secure, citizen centric, at scale. So the impact is tangible and mm, strong security that maintains public confidence, operational efficiency that frees staff from complex cases, low code delivers citizen centric services at scale. Metadata driven architecture, the foundation of flexibility. At the core is configuration over customization. Metadata allows rapid change without overwriting. This reduces the technical debt and accelerates response to policy changes. Understanding the metadata layer. The metadata layer is the bridge, platform, core, and configuration application. It enables the change without touching the code. This is what makes agencies adaptable to evolving metadata. Citizen journey mapping from request to resolution. Low code enables end to end citizen journey, request submissions, automated processing, agency review, service delivery, feedback, and optimization. Each step is transparent and efficient. Empowering citizen developers, building capacity within agency. Low code empowers non-technical staff with training and governance. Citizens, developers build solutions close to the problems. Low code does not replace engineers, it amplifies them. Continuous improvement through iterative development. Low code supports iterative development, rapid prototyping, user feedback, continuous refinement. This reduces the risk and improves outcome. Scalability and performance, meeting the growing demand. Cloud-based low-code platforms are scalable automatically. They handle peak demand without service disruption. Performance remain consistent even under heavy load. Future-proofing government services, preparing for tomorrow's challenges. Low-code, future-proof services. AI and machine learning can be integrated without massive rewrites. Agencies adapt quickly to new mandates and evolving expectations. Key takeaways and next steps. Metadata driven low code is a strategic enabler. Salesforce capability addresses real government needs. Results are proven at scale. Success comes to Su- Success comes from incremental adoption and strong governance. Thank you. With this, I want to end my speech by saying modernizing public sectors is not about building faster apps. This is about restoring trust by delivering services that are accessible, secure, and adaptable. Thank you so much.
Thanks very much. And that was a great presentation. Um, any questions, anybody? One second now to see if there are any coming in. No, we're all good. Um, Straight and to the point, and yeah, we see low code creeping into everything today. Um,
Yes, sir, it is.
yeah, all these agents that we see now, they're all low code.
Mhm.
Um, so, Biznek, over to you there. So I'll put your screen up. There you go.
Thank you so
Secure
much,
and
everybody.
governed AI solutions.
Thank you, Frank. Yes, in the following minutes, I will speak about securing governing AI solutions. Why this? Because we see many companies, let's say, are going from experimentation to deploying to scale. But the biggest challenges, especially to structured industries, organizations like especially banking, insurance, healthcare. It comes here no more, let's say, to accuracy, to model accuracy, but it goes to governance, to security, compliance, and all the following slides are based on uh, the experience from the last 2-3 years working with such clients. And I will share here like a framework, organization, like what we should go through to be compliant with such industries, especially in companies with very restricted laws or very organized laws like Switzerland and other European companies. Before starting, I'm Fisting Doko, Microsoft Certified Trainer for 11 years. I work as a senior Azure AI architect, but also as a Microsoft trainer around the world, delivering various courses, especially in the last 4 years about AI. Okay, I will continue with the topic, and all this comes because now generative AI, it comes with some unique risks, like with privacy concerns, unpredictable behavior, some content safety challenges, and exposure to new forms of attacks like prompt injection, which are different, like what we have been learned before. That's why we need somehow a new way of protection and organization against that. As we begin this session, it's also important here to recognize that the generative AI, it's much different from the traditional. And here we have that those differences in like 3 pillars, where here the first point is about understanding the performance trade-offs for agentic applications, which agent-based systems now can call tools, can connect to APIs, can access some data, can make decisions in real time. This means that performance now is influenced by model latency, and also here we need monitoring, evaluation, which are no more optional. We need them to keep the system predictable over time. What's also important for us now is this second pillar, that we are facing with new types of attacks, and the attackers themselves are also using AI to attack these AI systems. It means a completely new area of challenges where the traditional security controls don't fully capture these threats like prompt injection, jailbreak, model manipulation, or data extraction. For this purpose, we need now somehow to deal more with this landscape, and also important challenges for such industries are privacy, security, compliance, complexity, also keeping to not violate any regulatory rules like GDPR, HIPAA, or industry-specific requirements. And for all that, here is the framework that I want to introduce and that I will also use in the next slides to describe stage by stage what is included in the same. Like at the foundation, we start with data governance protection because every system ultimately learns from the data, and if the data is not classified, protected, or governed, everything built on top, it will become risky. Additionally, then we introduce here the identity for humans and agents, which in modern AI systems, it's mandatory. Like a third layer here is shown the safety system, guardrails. Then we move with risk management, policy enforcement, and then above that we have for sure observability, monitoring, which gives a continuous visibility into how AI systems behave in production. And then also we have here evaluation, quality assurance, which are continuously run. And finally, we have the red team AI agent, like not doing a red team manual, but the agent, which assumes that our systems are now are protected, and through attacking our systems, it will test using its techniques. Let me start stage by stage here, what we have in every stage in this framework. We start with the data governance again here, because every AI risk starts with data. And these AI systems don't just store data, but also they reason over it, they combine, and they can expose them in an unexpected or unpredictable way. That's why if data is not governed properly, then we can have big security issues. For this purpose, in Azure is strongly recommended to use the Microsoft Purview, which gives a centralized data map catalog, so we know exactly what data exists across organization, where it lives, how it flows, how it's labeled, how it's classified. And then after having this, we can be ensured that sensitive information cannot be exposed through prompts, responses, or through AI integrations. Also, we need here to have in the we have mentioned the data security posture management to understand the risk across models, prompts, embeddings. And finally, we have also the part here for policy-aware data interactions. That means that even a user or an AI agent asks for data, access is still evaluated against this governance, compliance, and policies, all that in real time. After the data governance, a critical step is also identity. We are speaking here for Azure ecosystem, Microsoft Entra ID, and now in Entra ID, we also have the agent ID. Agent ID or identification for the agents means now we can control these agents, where can go, what can do, and this access now can be controlled using especially the RBAC or also the ABAC. Additionally, on top of this, we can use conditional access, adaptive access control, and also for all these, normally now we have and audit logs, access lifecycle management to ensure traceability and to be sure to answer if later something happens, like who accessed, which agent performed the action, and this is very helpful for production systems. The next layer in this framework is the safety system and the guardrails. This is what controls how AI behaves in real time. And especially here, the central part is the content safety, which provides like native safety capabilities across text, image generation. It is about incoming prompts, about output. It controls both, and it does a lot of help for us, especially here it does, and the protection for prompt shields, like defending against direct, indirect, inject attacks. Also, these attacks can try to manipulate the model, let's say to ignore the instructions, and this prompt shields helps a lot in that purpose. Additionally, we have here a way of blacklist. We can even hard code define the black words, And for agentic AI scenarios, in this part, we have also the task adherence and action boundary enforcement, which are essential that can ensure that the AI agent can perform only actions that are allowed to do. With safety guardrails in place, the next layer focuses here on risk management and policy enforcement. And this is where AI governance becomes truly operational. And organizations usually already have policies around data usage, security, and compliance. And the challenge with AI is making sure those policies don't stay as documents but are actually enforced by the system. Additionally, we have the organizational AI usage policies, which define how AI can be used for which scenarios. We have also here responsible AI guidance, which ensures alignment with ethical principles such as fairness, transparency, traceability, accountability. We have compliance, regulatory alignment. For agentic AI, also it's important this threat modeling, which uh, which introduces a scenario that must be identified, mitigated earlier, and also we have the AI uh, AI safety system to enterprise control, which ensures the policy violations can trigger alerts, restrictions, or also remediation actions automatically. After the governance, policies, controls, and forwards. Then we have the observability, where governance without visibility simply it doesn't work. And for this purpose, Azure AI Foundry, it comes with observability stack, which provides a centralized view into AI applications, models, agents. Like we have also centralized tracing, also including logs, latency, performance dashboards. We have also cost governance. Also, we have details about the models like model usage, and all this is integrated into Azure Monitor, where we can see these logs, these metrics, and for sure we can configure and alerts. Observability tells us what is happening in production, but also we need an evaluation and quality assurance, which tells whether the AI system is behaving as intended or something is not going well with the quality. And that's why here for evaluation, we have many ways, starting from manual, automated. We have automated model scoring. We also have safety scoring, alignment checks, data-driven also evaluation, and important, we have also human in the loop review, which is also critical and nowadays. And finally, we can do here some benchmarking via scripts to allow teams to compare models, prompts, uh, configurations over time about any improvement or about any rollback. And finally, in this framework that we saw, the final layer is the red team AI agent, which is where we explicitly assume that our AI system will be attacked. And if we compare with traditional security, this red team is well-established practice of people from different, let's say, industries, intelligent people. But now with this agent, everything is replicated through agent. We have this agent through AI Foundry, which can continuously, uh, in automated way, can test our models, our agents, and instead of waiting from ourselves to do something, it does by integrating with Pirate, and it simulates attacks, and with that we get results about this continuous uh, discipline of attacking and defining a trust about our AI system. We saw seven stages in this framework. For sure, as much as we use from these points that we mentioned, that is better. But having at least one, two of these items from every stage. It's mandatory, especially for highly compliant systems. And despite this framework that we saw, we have here in the last slide about the governance, where the governance, it isn't just a checkbox. Like it's a framework that keeps AI applications safe, compliant, trustworthy. And we have a diagram here that shows how Foundry, Microsoft Security, and Preview, they come together to provide end-to-end governance model from the start, from input, going up to model and coming that output. What we see here the application context. This is where developers design, customize AI applications. And then here, as part of this workflow, we have two important protections in place, like we have the part for prompt attacks, which are blocked, also for sensitive data labeling. And then as the traffic goes from the application to the Microsoft here uh, box or Microsoft parts, we have also a defender, which enriches the threat intelligence. It recognizes also suspicious behavior based on some patterns, global knowledge it has. And then from there, we have two groups that get actionable insights like the SecOps teams and the data security and compliance teams. And the result here is like a closed feedback loop across development, security, and compliance teams. And all this happens into the Foundry by the help, in this case, also from data purview to enforce data governance. And then together, all these, they provide a complete enterprise-grade control over the AI applications. I tried to be in the time frame. I hope I respected the time frame. Maybe it was a bit too fast, but I wanted just to complete as was planned. Thank you. Any questions, please?
No, that was perfect timing. You covered it really well and clear. Um, so I just want to know, is there
Yeah, I think that's a nice presentation. So I think I just have one question for you. So what role does the zero trust architecture play in securing AI workload?
Uh, in reality, in the last, as I mentioned, 20 months or more, we had a lot of applications, especially in the banking industry, which worked well like a proof of concept. But then going to production, we had big stoppers, especially the part with Microsoft Purview and other compliance rules. And that was like a blocker. And after having these issues, we accumulated, it wasn't just with one customer, with more customers. And then we accumulated that knowledge and we brought together with the team this framework, like suggestions, recommendations, and all then what we choose. Normally, it's done in a collaboration with the client, but this is like a recommendation part coming also from Microsoft documentation, from the real experience, and then providing all this to the customer to help them to decide to show to them where they are, what they need in order to be covered with all this governance and security part.
Okay, fair enough. Yeah, thank you.
Thank you.
So that's it. Anybody have anything else?
Yeah, I think that was a good presentation by all the speakers tonight. Yeah, they really did justice to the presentation. Precious, thank you for being the only female here, and you're actually outstanding. Thank you for coming. Yeah, I really love your boldness and confidence. Yeah, thank you.
Okay. So I'm just going to end the live show. Thank you, everybody, for joining us this week. Great speakers, great presentations, everybody. And we'll be back here again next week at the same time. with some more new speakers. Precious will be here again with us next week for some more stuff on Azure. And we have another 3 new speakers lined up. So thanks, everybody.
Oh, thank you, guys. Yeah. Bye.
Thank you.
Thank you, Stephen. Thank you, everyone.
Yeah.